Okay, and you know that whenever you are going to have a series component, you will be finding out voltage gain. Whenever you are going to have a shunt component, you will be finding out current gain. But since you are going to have the capacitance in series, I am finding A is going to be the voltage gain. So, you know, capacitance in parallel will get added. So the effective capacitance is going to be addition of both C B dash E plus 1 plus GMRL into C B dash C. So I can find the cutoff frequency using F is equal to 1 by 2 pi RC. RC is this resistance parallel to this two capacitance in parallel. So I'm denoting that by capital C. So F2 will be equal to 1 by 2 pi RB dash E into C. This is going to be the upper cutoff frequency. See, always at high frequencies, the upper cutoff frequency is decided by these capacitances. Okay, in the low frequency, they will not have any effect. So low frequency analysis, we will not concentrate on these capacitors. At high frequency, the high frequency cutoff frequency is decided by all these capacitances, which is going to be present between the junctions of B dash, E and C. மூணு capacitor இருக்கும், but we are going to focus only on two because the third capacitor between collector and emitter is going to be of a very, very lesser significance. So I am going to neglect that capacitance in all our analysis. Okay. And when you consider the source resistance also into account, so F2 will be equal to you, the upper frequency will change. It is 1 by 2 pi R dash into C. And what is R dash is the effective resistance from the input side. So in the input side, if you see, R dash will be, RS will be somewhere here. Okay. So RS will be somewhere here. So if you apply the input, how to calculate the input resistance, you can say RS and RBB dash is parallel, which is in series, which is in parallel with RB dash E. The RB dash C across you see RBB dash and RS are in series, which is parallel with RB dash E. So that is for the expression. You can RS plus RBB dash parallel to RB dash E. So you simplify R1 parallel to R2 is R1 R2 by R1 plus R2. So RS plus RBB dash into RB dash E divided by RS plus RBB dash plus RB dash E. You know that the combination of addition of these two resistance is going to be HIE. So RS plus RBB dash into RB dash E by RS plus HIE. So this is the equivalent resistance when you take the source resistance RS into account also. So remember, the RS and RBB dash are in series, which is parallel to RB dash E. So RB dash E paranga in the entire resistance. Across this, you find the series combination of these two. Series now you will get added. So RS plus RBB dash, which is parallel to RB dash E. Okay, and the total input capacitance is going to be same. CB dash E plus 1 plus GMRL into CB dash C. So if the effect of biasing resistor are also taken into account, then you have to R1, R2 is also taken into account. Then you have to consider them also. So you know by default RB is R1 parallel to R2 and RS dash will be RS parallel to RB. So all these biasing resistors will come parallel to all the components. So this formula will change slightly. So parallel combination what will happen? The resistance value will start lowering and the cutoff frequency will start increasing. So remember all these resistances externally what you are going to add into your transistor, they are going to strongly influence the 3 dB, upper 3 dB cutoff frequency of your amplifier. So F2 is 1 by 2 pi RC, right? So if the resistance value is smaller and smaller, the cutoff frequency is going to be larger. So your transistor will slowly move into high frequency region of operation also. Okay. So any doubt in finding out the high frequency current gain of the amplifier with load resistance? So any queries if you have, you can ask. Are things clear? Any doubts you have in this topic? It's a very small topic. Last class, if you have understood, we have found the short circuit current gain. Now we are doing the same thing with load resistance RL, and we are also applying Miller's theorem. And we are seeing what all parameters are influencing the upper cutoff frequency of my amplifier F2. Okay. I hope the things are clear. So we'll go to the next topic, which is the last topic in Unit 2. It is multi-stage amplifiers.